This will take probably 20-25 minutes just to show you an example of what's called a galvanic cell. And so we're getting into basically electrochemistry, and we're going to look at two things, two basic ideas in electrochemistry. We're looking to see how electricity can be produced chemically, and we're going to see how electricity can convert certain elements and reduce them in which to produce, solid metals from a solution. Okay, so electrochemistry studies the interchange of chemical energy to electrical. So, if you take a look on page 709, these are a table that you'll use, and these are all half reactions that are reduction reactions. So everything on this page, electrons are being added to a certain molecule or ions in which to get them to be reduced. Now, some of them you see they're in acidic solutions, and I don't really think we'll probably do any problems where it's in acidic solution. But can you kind of guess which ones are in acidic solutions there on that page 709? Yeah, pretty much the ones that make water, I would say. Yeah, the H positives, right? So where you guys have 4 H positives, and especially that one, it's H positive and SO4 minus, that's going to be sulfuric acid. That's going to be in. And so if you look down through there's some that are in acidic solutions. But we're going to kind of maybe not really worry too much about those because that's just an added. We don't have really a whole lot of time. We've got a week to go through some of the concepts in this chapter. We're not going to hit everything, okay? We just don't have the time. Once you get to chapter 18, you're kind of pushed for time, and then I want to use all next week to review. Even if you're not taking the AP test, that's something we're going to do, okay? I think we'll have like a 50-point quiz, and so it'll be kind of like a half test. And so part of it will come from the assignments we did on chapter 16. And then we skip over chapter 17, because chapter 17 we've already done, because that had to deal with entropy and Gibbs's free energy and see if it's spontaneous and it's non-spontaneous. You guys remember some of that?
Do you have the retake for the last test ready?
No, I don't. So, these, now, if you look at the top left-hand portion, these are more likely to happen than the ones down below it. So if we're pairing up F2 plus 2 electrons, and we got the arrow and it makes 2 fluorine ions, that is most likely to happen because what do we know about fluorine? Do they tend to want to gain electrons or lose electrons? Okay, gain electrons. Okay? If you look at the bottom right, it's lithium plus. So on that one, does lithium tend to want to gain or lose electrons? So lithium metal, it tends to want to lose. Okay? And so that's probably not likely going to happen, the one on the lower right, because lithium, potassium, barium, they all want to basically have a full outer shell, and they do that by losing electrons.
So do they go the opposite way then? Yeah, because they're negative.
If we would flip the arrow, which we're going to be doing on some of these, then we flip the sign. The sign flips.
So like if you put like in this little illustration thing,
Mm-hmm.
if you had one that was fluorine and one that was lithium, would that work?
But you'd have to flip the lithium because both of them can't be reduced.
Right.
You got to have one that's oxidized and one reduced to get to where it produces an electric current. Okay. So when we pair these up in a full reaction, we're going to have one of them that's going to flip its arrow and flip its sign. But we're going to give you an equation that flips the sign automatically. So, okay. So, just give you some terms that we're going to be taking a look at. So, we're going to look at a galvanic cell. That's what they call these. It's basically a battery. And it's going to be producing an electric current as in voltage. So, we're going to be able to calculate some volts. So, this is where chemical energy is transferred into electrical. Now, it looks like this definition here, but we can also go from electrical to chemical. So we can actually, like when you plug in your phone, okay, when you plug in your phone, your device, it's got a battery in there that when you